Good morning, everyone. Are you as excited as I am? Are you as sleepy as I am? I got up at 5 o'clock this morning. But I'm very happy to be here. My name is Robert Katzschmann. I'm an assistant professor of robotics at ETH Zürich. I'm also a co-founder of Mimic Robotics, and I have the honor today of moderating the first session, the first keynote session on the topic of sustainability robotics. So, just a quick background, I work on soft and biohybrid robotics, and we take a lot of inspiration from nature for this work, and we're trying to build systems that are as efficient, or potentially as efficient, as what natural systems can be. But I think as robotics advances at the currently perceived extraordinary speed, so thinking of these household humanoids that we're seeing announced, also as we see construction-scale systems, autonomous systems emerging more and more, I think it's important to take a step back and ask ourselves the question, what is the long-term footprint of all of these machines that we currently designing, perceiving, and creating? I think the innovation in robotics often pushes us towards questions of materials, energy, and also the end of life. And we don't think about these life cycles of our robots, what they're made of, what's the energy they consume, and also the waste that they will leave behind once we basically don't need them anymore. So I think this increasingly defines real impact. And today's session is really about shifting the focus from what robots can do to how they should do it. So just to give you a bit of a framing of this, if we look at the current UN Sustainable Development Goals, I think robotics can actually contribute to most of them. I looked it up, I think 13 out of those 17 goals can actually be impacted by robotics, by being more efficient in production, by reducing waste, but also by improving environmental monitoring. And I think the burden of robotics on the environment is steadily increasing. We have rare earth metals that we have to use. We have very energy-intensive manufacturing. We produce a lot of electronics waste, and we have to have a huge learning machinery in the data centers that's going to support all of this. And while companies claim they're actually highlighting sustainability, if you actually look, they're not really truly circular and resource efficient at the moment. I ran some numbers. We all talk about humanoids. And if you actually go by the analysis of Goldman Sachs, Morgan Stanley, and also UBS, they say that the market will have tens of billions of humanoids in value. And it will be hundreds of millions of humanoids by the year 2035, between 2035 to 2050. And the market will grow between tens of billions to eventually trillions in value. If you scale this now with materials, it shocked me. If you, for example, think of all of the neodymium magnets that we would need in each individual joint of these robots, of the lithium-ion cells for every single pack that goes into these robots, or the copper of wiring and windings, if we have 1 billion humanoids with about 2 kilowatt hours of battery cells in them, it would take us 200,000 tons of lithium, 1.5 million tons of nickel, and tens of millions of tons of copper just to build these humanoids. And I don't even want to talk about the magnet demand. It will be far beyond what we currently have, which is about 100,000 tons per year of magnets. So if you think about this forward, and I don't want to go more into these numbers, you get the idea. It's not, I don't want to alarm, but we need to rethink of how we build these systems. We truly need to think about what's our responsibility here of designing robots, not just simply with what's convenient right there, but to think about how we build the future of robots using materials that truly can actually scale. So today we will ask 3 questions in this session. How do we design, manufacture, deploy, and retire robotic systems responsibly? How do we balance innovation with environmental reality? And the third and last question is, how can fields such as soft robotics, biohybrid robotics, sustainable construction, environmental robotics, and also precision agriculture offer new paths forward?